Howdy Pre-Cal, it's Ms. Kosh. I am going to do an intro video and then send you to my video that I had done in a previous year. I typed up the notes from the previous year in a way that's a little bit nicer to look at. And I want to talk through this chart and then let you go do the other examples with my previous video because I need to save time. So once we get through this chart, then I'm gonna send you to the other, and there might be a little bit of a repeat, but just think you can either speed me up or do the 1.5 speed or whatever, or you can just hear it twice. So that'll be great. So like we talked about with circles, every conic section can be defined by how we slice the cone, and it can be defined by distance. So on the ellipse, what we get is when we slice the cone with a plane that's not exactly parallel to the base. I saw somewhere, let me see if I can find, if I still have it up. No, okay, I don't remember it off the top of my head. They described what angle it would need to be in order for it to be an ellipse, but basically if you can see this right here, what we find is that if it were perfectly parallel to the base, it would be a circle, but this is now a little bit angled, and that gives us that ellipse shape. Okay, we can also define this, I always put my name on everything, we can also define this in terms of distance. And an ellipse is defined as the set of all points in the plane, the sum of whose distance from two fixed points and those points are called the foci, is a constant. Okay. So it's the set of all points in the plane, the sum of whose distance from two fixed points is a constant. So here's what's happening. We have something that's elliptical shaped like this. We've got a foci here and a foci there. And then we can look at the distance, any point here on the ellipse. This piece, the distance from the first foci, and this piece, D1 and then D2, D1 plus D2 is always constant. Okay, this is where I want you to go watch that other video. I would redo that video, but Flash Player is no longer working on my devices. So that video is good. It's worth watching. You could pause here, go watch it, come back if you'd like, or watch it after you finish this one. I just think you should watch both of them. All right, so what we have here is we're given this equation. This is the standard form of an equation of an ellipse. And you'll notice that it's pretty similar to a circle, except, now think about this for just a second. If these were both the same, so if I said x minus h squared over r squared, I didn't want to make that, plus y minus k squared over r squared equals 1. If I multiplied everybody by r squared, I would get I'm not getting that. X minus h squared plus y minus k squared is equal to r squared. And that's what you saw when we looked at circles. That's the equation of a circle. What's happening here, this is very similar to that, but we could have a different value in the x direction and a different value in the y direction. Okay, so just like in a circle, the center is hk. The horizontal ellipse, okay, so it's a horizontal ellipse. It means it's wider than it is tall when A is greater than B. So when I move more in the x direction than I do in the y direction, it's going to be horizontal. Okay, so this is horizontal. And then it's vertical, something like this, when A is less than B, or when B is greater than A. And so that means you've moved less in the x direction and more in the y direction. So the vertices are always on the major axis. And so in a horizontal ellipse, we have moved from the center, we've moved in the x direction this A amount. So what we'll have here is, so this whole, my thought here with this chart is that this column is all dealing with a horizontal ellipse and this column is all dealing with the vertical ellipse. Okay, so if we're looking at the horizontal one, we have to move A units from that center. So that means our center is going to be, well, it's H plus or minus A, and then our Y value stays K, because that's the center. So think about this for a second. Let me get rid of this with this word right here. What we're doing here was the center. We have taken, this is the point HK, and now I have moved out to my major, to my vertices on my major axis, and I have moved out A units. So it's H plus A, but my Y value did not change. And then over here, I now have an H minus A and then a K value for the same Y. Okay, now the co-vertices are on the minor axis. So that means I have to move up to this point, and I'm moving B units to get there. Okay, so it's kind of like radius, except it's not, because they could be different. So the minor and the major axis could be different from each other. Another way to say that is that the circle is a subset. Circles are a subset of ellipses. So what we've done here is, and for this point, these are our co-vertices. We have moved, our x value has stayed the same, but now our y value, we have to add and subtract b. Okay? Let's do the vertical one at the same time as when we look at this one. So here's that center, HK. So now our major axis is this one right here. So we need to come up to this point. Our H value has stayed the same, and our K value, we have added, this one we added B. Oh, did I finish that other one? Oh, this was, I didn't write it there, but this is H, this is a K plus B, and this one was that H, K minus B. That got, I was talking about this point and this point. Anyway, got distracted. Okay, this then becomes the x value is the same, and then we start at the center, and now we subtract away that b value. So when the ellipse is vertical, the vertices are going to be h and then k plus or minus b. There's two vertices. I'm just writing them as one expression. Now our co-vertices are going to be on the minor axis here and here. So now we are changing our x value. So it's h plus a, k, and then h minus a, k. So here we have h plus or minus a, comma, k. To be perfectly honest with you, I don't memorize these formulas so much as I know how to get there. Okay, so I find the center, I figure out what that point is, and then I move A in the X, and I move B in the Y, and I put my points, and then I figure out what those coordinates are, and I move on with my life. Okay, the next thing is that the foci, now those are those 2 points right here, where we said from the foci to any points, and then that point back to the other foci, that distance right here remains constant. Go watch the other video. We find that by saying c squared is equal to the absolute value of a squared minus b squared. Okay, and they're always on the major axis. So when the major axis, and we move that many units away from the center. So we're going to come c units away right here, and then c units away right here, and then on this one we'd go c units up and then c units down. So what we have is h plus or minus c, and then k stays the same. And then we have h k plus or minus c to get the foci on the vertical ellipse. Okay, so I am going to be true to my word. I'm going to stop here and send you to my other video. If I don't have these 4 examples worked in that other video, which I probably do, I will make another video. But at this point, go watch that, and then I'll go look and make sure I covered what I needed to. All right, good luck. Go practice.